look at number, what did you say it was, number 3? Okay, make sure that's on there. Okay. All right, so let me turn to my, okay. Yeah, I get 45 also. Is that what you said y'all got, 45? Yeah, I got 45 also. Yeah, but we'll go ahead and look at it, okay? Yeah, so remember I said that sometimes there are errors here and there. Not too many, but there are a few here and there. Okay. All right. Okay, so number 3, what page is that on? Page A93? 93? All right, good. So let's look at number, this is on page 93. Number 3, all right. All right, so we got a web page designer creates an animation in which a dot on a computer screen has position. All right, so I'm just going to do this right here. I'm going to draw it, and I'm going to put the dot right here. And it has position of R what? So R is equal to 4 centimeters plus 2.5 centimeters squared per what? Centimeters per second squared, centimeters per second squared. And all of that is in brackets, right? And that's T. Ah, gummit. My bad. Okay, I need to just slow down a little bit. Okay, so that's centimeters per second squared, T squared, bracket I caret cap. Very good. Plus 5 centimeters per second T square, J, right? And let's do that. 5 centimeters per second T. Shoot. All right. J caret cap. Okay. Y'all, if I don't put the caret cap on there, y'all gonna freak out? I will? You will? Okay. All right. Okay. All right. Okay, so always, of course, draw it, label what you can as you go. Find the magnitude direction of the dot's average velocity between T0 and T2.0 seconds. So we want to find the velocity average, and that's A, from T is equal to 0 seconds to T is equal to 2 seconds, right? Okay. All right, so we want to find the average velocity from T0 to T2 seconds, right? Okay. All right, so a couple of different ways we can do this. We can take our equation, and notice this is R. And R is what? Position, which means X and Y. Well, notice that we have an X component and we have a Y component, do we not? Is that correct? Okay. All right, so, okay. All right, at time 0, if we go up here and plug in time equal to 0 right here, and I forgot my T out here. Now there's my T. Right there it is. What are you going to get? If you plug in a 0 here and plug in a 0 right there, what happens? What's left? 4I. Yeah. So, at time 0, X is equal to what? Or R, we can say R, is equal to what? 4 centimeters I, right? At time 0. Okay? All right. Now, what will R look like at time 2 seconds? And maybe I should have just done this. Let me back up. Let me just keep it R. Keep everybody happy. All right. So what is it going to be at time 2 seconds? Well, plug it in. So we've got what? We got 4 centimeters plus, all right, is that 2.5? 2.5 centimeters per second squared times what? 2 seconds squared plus what? 5 centimeters per second times 2. And of course this is I, brackets, brackets, that's I. And what is this right here? This is J, isn't it? And by the way, what was our J component on the top at time 0? It was 0J, right? 0. Okay. So what does this come to? This comes to what? The time at time 2 seconds. Let's see what our R is. R is equal to what? Well, we got 4 times 2.5 plus 4, and we get what? 14? So that's 14 centimeters I, right? Plus what? And by the way, yeah, and that was second, right? 10J. All right, this is squared. Squared goes, and you're left with centimeters. It cancels out. You see that? That's okay. All right, now those are the components. Does everybody understand that those are the components for both time intervals? Notice you've got an I component. You don't have a J. We could say 0J, but we don't need to because it's not there. And then we have a what? 14I and 10J at time 2 seconds. Does everybody agree with that, right? Okay. You square, that'd be what? 4 times 2.5 is what? Isn't that 10? Okay. Plus 4. Now the square, what goes away? The squared seconds goes. Squared seconds. See that seconds and it becomes squared? Is that okay? Is that what your question was? Okay. All right. Sorry about that. I didn't mean to skip over that. Okay. Okay? All right. Everybody good? All right. So now it wants to know what? The average velocity, right? Now I know some of you might be thinking, well, we should take the derivative. No, because it said, remember, derivative is to find instantaneous. Okay? If it had said, what is the instantaneous velocity at time 0 and at time 2, then you would have taken the derivative of that function and we would have gone with it that way. But that's not what it asks. It says average. Okay? All right. So how do we do it? Well, we can do it one of two ways. We can do it by the X and by the Y, or we can do it by what? Okay? So at time 0, it's what? 4 centimeters? So I'll tell you what, let's do this. Let's do the velocity average in the X direction, or the I direction. All right, so what are my X components? Well, now what is velocity average? The change in X over the time interval, right? All right, we got 14 centimeters minus 4 centimeters divided by, what's the time interval? 2 seconds? And what do we come up with? That's 12 divided by, is it 6? No, 10. Why did I get 12? All right. 5, what, centimeters per second? And we were going to call that X, or if we want to, you could come in here and say I. Now let's do it for the J. Velocity average in the Y, or if you want to use J, okay, you can keep it that way. All right. So what do we get? Well, we got 10 minus 0, don't we? 10 centimeters minus 0 centimeters divided by what? 2 seconds. And what do we get? 5. Yes? Okay. Right? All right. And we could write it this way. We could come in here and say, now the velocity average is equal to 5 centimeters per second I plus 5 centimeters per second parentheses J. Okay? You could write it that way. Okay. All right, now, how do we find the angle? What's the second part? Is that what the second part is? The magnitude and direction of the average velocity. Okay. All right. Well, how do we find the magnitude? Notice that's components. Notice that's X and Y, I and J. I mean, come on, y'all. I don't need to flip-flop that, do I? I mean, if y'all know if I'm saying I'm X, okay, come on. All right? Well, how do we find it? All right, well, we're looking for what? The resultant, aren't we? We're looking for the resultant. We're looking for this right here. Right? Okay. Well, we just do the square root of the squares. And I'm going to put R for resultant. That's magnitude. And so we do what? We'll do 5 squared plus what? 5 squared. That's all on the radical. And what do we get? 7.1? 7.1. Magnitude. Is that good? Does that make sense? Okay. All right, now, how do I find direction? Inverse tangent, yeah. So we do arctan. So arctan. And we got what? Well, foot. It's what? 5 over 5? Is that right? And so theta is what? 45 degrees? Isn't that what we all agreed on? Yeah. Okay. Can we do that? Yeah. Now, look, here's my angle. And that's supposed to be coming from the origin. My bad. Let's fix that. Y'all knew what was going on, I hope. There it is. Okay. 45 degrees. Okay. Very good. All right, any other questions? Well, we've run out of time a little bit. Okay. Now, again, all right, let's hang on a minute. Let's talk about what we're going to do Wednesday. Now, you know lab's coming up here at 12:30. And it's not a